Good morning everyone, and welcome to the final calculation-based worked exam answer video that I'm going to be doing for a while before I switch my focus onto some other areas that have been requested, such as organic synthesis and required practical questions and questions that are focused on some of the year 12 content that you might still be expected to get in the main body of the paper 1, 2 and 3 exams. The multiple choice will cover everything, but there are certain topics from the year 12 areas that commonly come up as longer questions, particularly on paper 1. Obviously with the organic, it kind of gets built into the organic synthesis questions, but that's definitely an area I'm going to have a look at as well. So I'm finishing off with this calculation. It's another multiple choice. There is again quite a lot to do in this question, and we're combining both an ideal gas calculation with using reacting moles and using mass moles and MR. So again, a lot to do for a 1-mark multiple choice question. Now, someone commented on that in one of my previous videos, and I just wanted to make the point that please do not worry, not every single multiple choice question will require the same amount of working out. There should be a good balance between slightly longer ones and multiple choice questions that you can answer fairly quickly if you have the information stored in your memory and can quickly recall factual details. They should balance themselves out. However, AQA do appreciate that the multiple choice questions are a lot harder than some people realise or give them credit for. So AQA suggests on paper 3, for the 30 marks of multiple choice you will have, to spend around 50 minutes. That indicates that they know that they're going to take a little bit longer than a minute per mark, and I would strongly recommend that you give the multiple choice questions that amount of time. Obviously it's up to you how you choose to approach the paper, do those first, do those last. That's something for you to think about, but I would definitely recommend practicing sets of 30 multiple choice questions and timing yourself and see how you get on with those. Anyways, back to today's question. I will do my annotating, my highlighting, my worked answer, and I will come back and explain this calculation to you. Okie dokie, so we're told in an experiment to identify a group 2 metal, which they've assigned the letter X. 0.102 grams of X react with an excess of aqueous hydrochloric acid according to the following equation. So X reacts with 2 lots of HCl to make XCl2 and H2. Now I've written above there that we've got a 1-to-1 ratio between the group 2 metal, which is what we're being asked to identify, and the hydrogen, and we're told the volume of the hydrogen gas given off is 65 centimetres cubed at 99 kilopascals pressure and 303 Kelvin, and we're then given the gas constant R as 8.31 joules per Kelvin per mole. So I've seen a number of different questions like this where you're given information about a gas that might be made in an experiment, but then you need to use the moles of that gas and the mole ratio in the balanced chemical equation to get the moles of a different substance, which you're then going on to find something out about. And the most common mistake I've seen with these sorts of questions is that students will calculate the moles of the gas using the ideal gas equation, and they'll do all that perfectly, but then they will assume that the moles that they've calculated is the moles of the other substance that they want. Now in this case, you'd have got away with that because of the 1-to-1 ratio. So the moles of hydrogen gas, which we'll calculate in a second, are equal to the moles of X in this instance. But if there were other equations where the ratio of the gas to the substance you're trying to find out about were not 1-to-1, you would then get that wrong. And there is another question that I'm thinking of where you make 3 lots of oxygen gas and you start with 2 moles of a reactant, so you need to use the 3-to-2 ratio. And because it was a multiple choice, they put in, AQA did, a multiple choice answer which would have been correct if you hadn't spotted the ratio. So as we said before, they're not silly in the alternative answers that they choose. We're given the volume of the hydrogen gas and we're given it in the wrong units. Ideal gas is the exception to the rule where volumes always need to be in decimeters cubed, except here where they need to be in meters cubed. So we go from centimetres to decimeters cubed by dividing by 1,000. We then go from decimeters to meters cubed by dividing by another 1,000. So we can go straight from centimetres cubed to meters cubed by dividing by 1,000,000, which gives me 6.5 times 10 to the minus 5 meters cubed. Pressure we've been given as 99 kilopascals, and in the ideal gas equation, pressure needs to be in pascals. So I've times that by 1,000 to get 99,000 pascals. Temperature needs to be in Kelvin, and it is. If you have been given it in degrees, add 273 and it will convert it to Kelvin. Gas constant will always be provided, and that's quite a big clue that we're going to need to be using PV as nRT if you weren't sure. So then I've written PV as nRT, and I've rearranged it to get the number of moles, because we need to get the number of moles of hydrogen so that we can get the number of moles of X, and then from the moles of X and the mass of X we can get the AR, which is exactly what I'm going to do. Now obviously this is a multiple choice question. I wouldn't be advocating you write all your working out down as you would for a longer question, because you're not going to get any method marks. So just write down enough for you to A, know what you're doing with your calculation, B, make sure you're writing it down legibly so that you know what the number says, you know what that number means, but you do not need to go into the level of detail obviously I have here for a 1 mark multiple choice, because the only mark you're going to get is the mark for the right answer. But to show you guys, obviously what I've done, I've written it out in full. So after rearranging the ideal gas equation, I've subbed in the pressure in pascals, the volume in meters cubed, the gas constant and the temperature, and I've worked that out on my calculator, and it gives me the moles of hydrogen to be 2.56 times 10 to the minus 3 moles. And that will only be doable for gases, and hydrogen is the only gas here, so the moles of hydrogen are 2.56 times 10 to the minus 3. Because of that 1-to-1 ratio in the balanced chemical equation, we do therefore also now know the moles of X to be 2.56 times 10 to the minus 3 as well. From the moles, we can use the mass that we were provided to get the AR. So mass divided by moles gives me an AR of 39.9, and when we compare that to the values on the periodic table, that value is closest to calcium, which is 40.1, and thus calcium has to be the identity of X. Hopefully that's been useful. If you do spot a question like this where the ratio isn't 1-to-1 and you've got a bit more work to do and you're not sure how to do it, please do let me know, or if you want to send me it to do as a worked answer, I'm very happy to take requests, as I've always said. Any questions about this one, obviously get in touch as well, and I will be back tomorrow with another video. Thanks guys!